Hello everyone, welcome to the R Masterclass series lecture 4. Today we are going to look at list, data frames and plots. So this is one of the most important lecture in whole R Masterclass series. Why? Because you are going to learn list, data frame and how to make plots that you are going to use throughout your whole data science career. So what is the aim of this lecture? So first, we know that the dataset organization is key to efficient data, and then it's eventually a good way you could do the data analysis on it. So to do the dataset organization, R provides some tools such as lists, such as data frames. So in this lecture, we are going to look at what is lists are, what our data frames are, and then we already looked at lecture 3 what is vector R. So then we are going to compare list versus vector, which one to use. And then the last lecture we are going to look at how you could do plots in R. With this, let's get started. Now it's time to look at what is list in R. So basically list in R is basically a collection of heterogeneous data types. So what do I mean of heterogeneous data types? Basically collection of different data types. So suppose here is your list, and here in this one of our data type could be a string in the index 1. Here it could be string. Similarly, here in other index it could be a integer, it could be in other index it could be a float, and in other it could be a double. Whereas in vector, this needs to be a homogeneous member, means the collection of same data type. So if we define a vector here, then if we define the vector here, then the index 1 here should be integer, let's say. Then the other index should also be a integer. It should be a homogeneous. So now we have idea, okay, what vector is, what list is. So now it's time to open our console. In lecture 3, we remember that vector is a collection of a homogeneous data types, means it could contain only a single data types element. And now let's define our vector with backward operators and assign a string data type. So let's say hello, and we close our double quote. Now our second index is integer that we have defined 1, and let's say one more index, let's say be a 3. Now you could think and pause this video and think about it. When I press enter, will it throw an error or not? Now here's the answer to it. It won't throw an error. Why? Because if we let's print our vector, here you could see that all the elements in the vector have been converted into string. Now to check whether vector contains any string or not, we have a method known as is.character, and it checks all the members that are inside the vec is whether in a string or not. So that method is known as is.character, and we pass vec, and here you could see that we know that whole data type inside vec is a string. And to iterate one more again, like what happening here is basically the vector that we have defined is again converted into string. So if we define, let's say vec and c, and here we define 1, 2, and our third data element is hello, will, or let us correct the variable name, will this throw an error or not? yes, it will not throw an error. So now if we print our vector1, you could see that whole thing have been converted into string. So once what our compiler does is basically see, okay, there have been a string is defined. Let us define all the other element as string. So here we define the integer which is converted into string. Similarly, 3 is also converted into string, and similarly here the our compiler sees, okay, 3 is an hello is an index 3, that is hello is a string. We need to define other data type of element to be string. Now we have got an idea, okay, how this works in vector. Now it's time to look at list. Now it's time to look at how you could define list in R. So to define list in R, basically we need to call list method, and a list method accepts any data parameters. So whatever you define will be stored in column, and the value will be stored in rows. So suppose we create list with backward operator, and here we define our list, which is A, which is a collection of, let's say, 3 integers, 1, 2, 1, 2 and 3, and we call this method. So what it will do is it will create a column with C, name C, and the values assigned to it in row 1 would be 1, 2 and 3. Now let's look how you could do in R console. So let us see, let us create a variable list container, and we define list which is x. Here x would be our column, and we define x is a collection of integers 1, 2, 3. Now we define y, which is collection of string, and it is valid in list. We know that because list is a collection of heterogeneous data types, so it could accept list, so it could accept list, also it could accept integer, it could accept itself, that is we know list, it could accept vector, it could accept integer, it could accept float, and it could also accept operators, it could also accept functions. Basically it could accept any parameter to it. So here we define ABC, and let's say we define Z, which is our column, and let us assign the values would be our boolean operation operators, that is true or false. Now we close our brackets, and it's true is not fine. So basically there is a typo. It's all needs to be a cap. Then here a list have been defined. So now let's see how this would look onto the row column. So if we look at the diagram of how list container or variable look like, it would look like this. So basically we have defined here in our console, if we open it, and we see that our first column is x with row members 1, 2, 3, and y was ABC and z was boolean operation, that is true or false. So here what our console would our compiler would do is it creates a x column and have rows as its value. So 1, 2, 3 would be the rows value of column x, y, z. Similarly, it will create a y column and values ABC string as the value assigned to it, and similarly it will create a z column and values assigned to it would be true or false. So in similarly how in vectors we assign was able to get the values from the list, similarly we could get the values from the uh, Similarly, how in vector we were able to get the values using square brackets, in vector we could similarly get the values in list using square brackets. So here let's open our console and let's clear our console, and we know the shortcut of this, that is Control L. Now to get let's print our list vector, list container. Here we get the value. So to get the value of x column, we could use square brackets, list container, and then we pass x to the square brackets, sorry, and this in double quotes we pass this, and we get the value 1 2 3. Let's clear our console, and now you could do the same for y and z. Let's look out how you could do this. List container, and then we pass in double quote y. We get the value that we have stored, which is string, and we get the value abc. List container, and then we pass the value z, then we get the value true or false. And here if you look that in list container it's a string, and in list container z it's a boolean, and in list container x it's a integer data types. So you could see that how it's able to store heterogeneous data types. Now I have a task for you. So if you need to define a empty list, how you could define? Let's see how you could define in list. So before we look into the list, in lecture 3 we remember that using numerical method we get the empty list. So let's call C, let's say vector, and then we assign a backward operator numeric, and then we define, we print vec, we get the empty variable vector. Here we could see empty. So to get the list, empty list, we just call a list method without providing any parameter to it, and once we print list 1, then we get the empty list. Now let's print list container and see what element it contains. So list container, and okay, so we have a typo, we remove, or at least we define our list container, and you could see list container contains the elements we defined earlier, that x column contains 1 2 3 integer elements, y contains string abc, z contains boolean true or false. Now let's see, now what would happen. Now what would happen if I define list container and I want to access the element indices from -1. So in here we have defined our list container, and say let's say list, and we call list -1. So what would be the output of this following command? So here there's just a typo, so it should be list 1. So once we press enter, we could see that the indices of 1 have been removed from the list. Basically in R, if you provide a minus indices, it just removes the row column of that index. So here we have provided -1, it removes the 1 index 1 index. And for this is not a safer method, because it could take any element and also just remove it from the index. What I mean is, suppose here is our list defined, let's say list is defined as 1 2 3, and we say let's remove the index -1, and it removes it, and our new index would be 2, 3. And here, what if you passed list index minus 5? Basically, it will go to the minus index of the list 5 index which does not exist and try to remove that element. And basically, that what makes this command unsafe. To safely remove indices from list, we need to use null method. And basically, before we see how to use null method, we need to see what does double square bracket means. So what if I call list1 and we call double square bracket, let's pass the called x that we have removed, so let's call y that we have defined and call it. So here it gives the value of that row column. So if we call z, it will give the value of that row. So we know how to use double square bracket to get the elements. Now let us redefine our list 1 and let's print our list 1. So here is our list 1, and now we need to safely remove the index 1, 1, 2, 3 from it. Let us call list 1. We call the x row, sorry, x column, and we say that now your value is null. And now if we print list 1, we get the value hello 2, which is safely we have removed the values from the list. Now it's time to look at some other methods that we are going to look at is append and nested list. So let us define our list 1. Earlier we have defined list 1. Let us define our list 2, which is a collection of list. Let's say A is equal to collection of C, and we defined our strings. This is the collection of strings. So let's say this is the collection of string, and now we define one more element. Let us say B, which is collection of element integers. So suppose let it be a integer, and then we call this method. Now let's look how you could make an append. So let us define list 3. We know to make an method append. We call append list 1. Then we call list 2, and then we need to make this appendment after index 2. So after index 2, and now if we print list 3, could you guess what would happen? So after index 2 from the list 1, that is x, y, the concatenation of list 2 would happen, and then the remaining list of 1 would be shown. So let's see what is happening. So here the list 1 index 1 is shown, then 2 is shown, and then after 2 we say to append the list 2. So here we get the A, B, C, D, E, F, that is index 1, then 4, 5, 6 of the column B is added, and then the remaining elements, that is Z, true or false, is shown. Now we have got an idea, okay, how to append the list. Let's say what would happen if we call list 3, we want to append after list 3, and we clear our console first and print list 3. Yes, now it's appending after index 3. So first concatenation of first 3 element is done, 1, 2, 3, and then no other element is remaining. So after index 3, the elements of list 2 is shown. Now what if I say you to do this with concatenation method with the C? So basically you could do similarly this method called concatenation, and it will concat list 1 versus list 2, and if you print list 3, here you would see the first index of list 1, list 2, list 3, and then the remaining element of list 3 is shown. Now let us clear our console. Now it's time to learn about nested list. Basically, nested list is a collection of list, or it could be a collection of list and vector. Now let us define, or let's see our list. So let us open our R console, and here we define our list 1, which is we define the backward operator list. Then we define X, which is collection of integers. Then Y, let be a string. C, and then Z is a collection of boolean. And now we define our list 2. Basically, similarly to list 1, list 2 is a list collection of, let's say, integer from 4 to 6. Let it be string, and Z it be true or false booleans. Now let us define our list 3, which is a nested list, which is basically a simple collection of list 1 and list 2. Now if we print here list 3, we get our nested list. As you can see here, nested list contains the elements of list 1 and list 2. We could also add vectors in nested list. So let us declare our vector 1, which is basically a collection of integers 1, 2, 3. And now let us define our list 4, which is collection of nested list and vectors. Backward operator C, and then we define list. We need to concatenate list 1, list 2, and then back 1. So here's just a typo. We need to fix. And now if we print list 4, we get the nested list, which contains list and vectors. Now we have got whole idea depth of list. Now it's time to learn about data frame. Now it's time to learn about one of the most important term, that is data frame. And data frame is basically used in data analysis, data manipulation. We will be using heavily this in plotting. And now we need to know what is data frame is. Basically, data frame and list are similar. The only thing that data frame differs from list is that data frame have the length of each member in data frame is similarly. So the column here, the length of this data member is similarly to the other column and similarly to the other column, which is not necessarily true for the list. Here the X data member have length 3. It's not necessarily for Y to have the length member 3, but it's necessary that data member here, let's suppose this is X and this is Y, the both have the lengths to be 1, 2, 3, 4 and 5. So the length should be 5, and so similarly the data member of Y should be having length 5. Similarly Z, if we define, should have data member length 5. Now it's time to look how you could define data frame in R. Now let's open our R console and define data frame. And the general rule in to define data frame, the naming convention is DF. So let us define our data frame, and it's defined by data.frame. We define the data member, let's say car, and let's say it's having values, let's say Tata, let's say Ford, and let's say Nissan. Let's add Suzuki, and here we have our data member of length 4. Let's close our bracket, and now let us define other data member, that is speed, and let's say the speed is for Tata is, let's say, any arbitrary number, let's say 100. For Ford is, let's say, 90. For Nissan, let's say it's 95. It's for Suzuki, it's let's say 97. Now we define one more arbitrary, let's say quality. We give the marks out of arbitrary number 5. Let's say for Tata we get 5. For Ford, Nissan, Suzuki we give, let's say 1, 2, and let's say for Suzuki we give 3. Now let's close our operator, close our brackets, and here we have an error. Basically we have one typo here, and if we here before we type enter we have a typo. We did not add concatenate in speed and in quality. Let's add concatenate the vectors, and now let's enter it, and now let's print our data frame. Here we get the data frame car, speed, quality. We have Tata, Ford and Nissan, Suzuki, and we have defined their speed, quality and respective arbitrary numbers to it. Now let's check how to get the row names from the data frame. So to get the row names, we type select row names, pass data frame, we get the row names, that is 1, 2, 3, 4, that we have rows, and to get the column names, that is car, speed, quality, we type col names, then we provide the data frame value, we get the column names. Now as I told you, data frame is a special condition of list in which all the data members have equal length. So if we check if data.frame, here we get so here if we check that is data frame is a data frame or not, df is data frame or not, it's true. What if I do this? Let's say is dot list data frame, what would it return? Will it return true or will it return false? So I hope you have confirmed your answer. Now let's press enter. It will return true. Basically we know that data frame is a special condition of list. Now let's say if you want to initialize a data frame 1 with value 0, how you could do it? We look at that in vector you could do it by numeric, in list you could do it by list, and in data frame it's similar, just say data.frame. So df1 we define the data frame method, just initialize it, and we get the data frame with value 0. Now if someone asks you, okay, if I want to add a data frame at the end, how you could do it? So we could easily do it. Let's say data frame, we define another value, let's say price, and here we assign the value to it. So let's say price value, and we need to define the 4 values, that is for Tata, Ford and Nissan. So we concatenate the values, let's say 1000, 1000, 2000 and 3000. And now if we print data frame, basically we get the price data frame 2. So let me go down, and here we get the price data frame. Now if you say, okay, we need to define also the data frame, but it should be at the front. So basically it should be before the car. So how you could do that? So basically for this we have a cbind method. So to define the data frame in the front of car, we could do this, a method called cbind, and then we create the column that we need to add. So let us say we need to add, let's say, door column, that how many each car have doors in it. So let's say doors, and it's a collection of integer vector, that is, say, let's say 4, 2, 4, and let's say Suzuki have 4. Then we pass the data frame that we need to cbind with it, and we then pass the data frame that we need to attach to it. So here we get the door data frame attached in front of car. Now let's look at one more method that is known as subsets. So let's say here is our, let us print out df2, which is data frame 2 that have door, car, speed, quality, and price data frames, and price column, sorry. And then what if we need to get the data which have quality greater than 2. So let's say data frame 2, and in this we need to get the subset of data frame 2 in which quality is greater than 2, and here we get the subset of from the data frame 2. Now we have learned how you could do multiple operation in data frames, how you could do multiple operation in list. Now let us look at how you could do some plotting in R. Now it's time to look at what plot is. Basically, plot is a visual representation of a data, and here we are just going to plot the value in X and Y. So to use plot in R, we have basically a method known as plot, and let's say to define in console, we first check what our data frame 2 is, and let's say we need to plot speed versus quality, let's say. So we call plot, and this, the first method, the first parameter would be our X. So here we call speed, and to access the column speed, we remember we need double square brackets, speed, we close the double quote, double square bracket, here we have typo, data frame 2 we need to access from, then we need to access quality, close the brackets, and then we enter, we get the plot for speed versus quality. And here we could see some have speed 92, 95, 94, 91, and then we have the max at 100. Now, so with this we could wrap up our lecture. We have learned how to plot a simple plot in R. We have looked at data frames, we have looked at vectors, we have looked at list. Now in coming lecture we are going to look at some more complex plots and how you could plot them. And with this I will see you on to the next lecture. Thank you everyone.